Bohr's theory of hydrogen atom. Bohr derived the expression for the radius of nth orbit of hydrogen atom and energy of the electron in the hydrogen atom. So according to Bohr's theory, a hydrogen atom consists of a nucleus at its center having the positive charge, and an electron is revolving around the nucleus with a negative charge having mass m and velocity v, and the radius of the orbit is r. Then to keep the electron in its stationary orbit, the centripetal force of the electron towards its center must be equal to the electrostatic force of attraction between electron and the nucleus. So we can write the equation centripetal force mv square by r, that is equal to electrostatic force of attraction, that is 1 by 4 pi epsilon 0 e square by r square. Then r and r will cancel. Then mv square equal to 1 by 4 pi epsilon 0 e square by r. Therefore, r equal to 1 by 4 pi epsilon 0 e square by mv square, that is equation number 2. Then according to Bohr's quantization condition, the angular momentum of the electron mvr equal to integral multiple of h by 2 pi. If the electron is in the nth possible orbit, we can write the equation as m Vn Rn equal to nh by 2 pi, where Vn is the velocity of electron in the nth possible orbit and Rn is its radius. So from this equation again we can write Rn equal to nh divided by 2 pi m Vn, equation number 3. So the equation 2 and equation 3 are equal. So we can equate, theoretically these two equations are equal. So we can equate these two equations. So we can write 1 by 4 pi epsilon 0 e square by m Vn square, that is nth possible orbit, that is equal to nh divided by 2 pi m Vn. Then m and m we can cancel, and the Vn and Vn also we can cancel. Then what we will get? Velocity of the electron in the nth possible orbit, Vn equal to, Vn comes to this side. So remaining 1 by 4 pi epsilon 0, then 2 pi comes to the numerator, that is 2 pi e square, then nh comes to the denominator, that is nh, equation number 4. So this is the velocity of electron in the nth possible orbit. Vn equal to 1 by 4 pi epsilon 0, 2 pi e square divided by nh. Then substitute this equation 4 in equation 3. There you substitute for the Vn. So substitute equation 4 in equation 3. So what we will get? Rn equal to nh divided by 2 pi m. Then this 2 pi e square comes to the denominator, 2 pi e square. Then this one comes to the numerator, that is 4 pi epsilon 0 nh. Then after, once again we can rearrange the equation. So we get Rn equal to n square, that is we can take it together, n square divided by m, put it in one bracket, then h square or h divided by 2 pi, that is 2 pi the whole square. So h by 2 pi the whole square, that is h square, then 2 pi the whole square, then remaining 4 pi epsilon 0 divided by e square. Okay, Rn, we get the equation Rn equal to n square by m, h by 2 pi the whole square, 4 pi epsilon 0 by e square. So this is the radius of the electron in the nth possible orbit. So from this equation we can write, or we understand that radii of the permitted orbits, okay, radii of the permitted orbits is directly proportional to, okay, radii of permitted orbits is directly proportional to n square, that is the principal quantum number n square. So we can write Rn is directly proportional to n square. Then other quantities are constant. H is the Planck's constant, then pi also, epsilon 0 also constant, then m, then E square, that is also constant, charge of the electron. So all these values are constant. Then only variable quantities is n. N represents the number of orbits. So we can write Rn is proportional to n square, n equal to 1, 2, 3, etc. So we can write n is the principal quantum number. N is called the principal quantum number. Okay, n is the principal quantum number. Okay, principal quantum number. Okay. Now we can calculate the radius of innermost orbit of hydrogen atom by putting n equal to 1 in the above equation. Rn equal to n square by m into h by 2 pi the whole square into 4 pi epsilon 0 by E square. So we get the equation R1 equal to, that is n equal to 1, R1 equal to 1 square. So remaining h square divided by m 4 pi square into 4 pi epsilon 0 by E square. So in the equation 4 and 4 we can cancel, and pi and pi square, that is pi cancels. Then we get R1 equal to, okay, R1 equal to h square epsilon 0 divided by pi m E square. Okay, so this is the first orbital radius and it is called the Bohr radius, and it is represented by the letter A0. This is known as the Bohr radius, represented by A0, that is equal to h square epsilon 0 by pi m E square. This is known as the Bohr radius or first orbital radius, that is A0 equal to h square epsilon 0 by pi m E square. Then by substituting the values of h, epsilon 0, pi, m and E, all are constants, we get the value of Bohr radius A0 equal to 5.29 into 10 raised to minus 11 meter. So this is known as the first orbital radius or the Bohr radius, and it is represented by the letter A0. Then we can calculate the total energy of the electron in the hydrogen atom. According to Rutherford's model, the total energy is En equal to minus E square by 8 pi epsilon 0 Rn. So following this one, Bohr calculated the total energy of electron in the end orbit of the possible end orbit of the hydrogen atom. So in the equation En equal to minus E square by 8 pi epsilon 0 Rn, we can substitute the value of Rn from the above equation. So we can write En equal to minus E square by 8 pi epsilon 0. Then we can substitute the Rn from the above equation, that is n square, then m comes to the numerator, then h and 2 pi comes to the numerator and the whole square, then 4 pi epsilon 0, then E square. Then we can cancel the terms. Then 2 square, that is 4, cancels. Then pi square, then here also pi, here also pi. So that also cancel. Then what is remaining? En equal to minus, okay, minus m e raised to 4, e raised to 4 divided by 8, okay, 8 n square epsilon 0 h square, okay, epsilon 0 square, then h square, that is En equal to minus m e raised to 4 8 n square epsilon 0 square into h square. Then by substituting the value of m, e, n, epsilon 0 and h, we get the value of energy in electron volt, that is minus 13.6 divided by n square electron volt. We get the value of energy of electron in the nth orbit in electron volt, that is minus 13.6 by n square electron volt, where n is the principal quantum number and n equal to 1, 2, 3, etc. The negative sign of the total energy means that electron is bound with the nucleus. Now we can see the numericals. So first one, calculate the shortest wavelength in the Balmer series of hydrogen atom. In which region, that is infrared, visible, ultraviolet, of hydrogen spectrum does this wavelength lie? So what is the formula to calculate the wavelength in the Balmer series of hydrogen atom? So you know the formula, that is 1 by lambda equal to r into 1 by 2 square minus 1 by n square. So this is the formula, that is empirical formula to calculate the wavelength of spectral series in the case of Balmer series. So here you want to calculate the shortest wavelength. So n equal to infinity. We can substitute n equal to infinity. So that is 1 by lambda equal to r into 1 by 2 square minus 1 by infinity. So 1 by infinity 0, that is equal to r by 4. 1 by 2 square, that is 1 by 4. So the value of r is constant, that is 1.1 into 10 raised to 7. Therefore lambda equal to 4 by r, that is equal to 4 by 1.1 into 10 raised to 7. When you calculate this one, you get the value 3.637 into 10 raised to minus 7 meter, that is equal to 363 into 10 raised to minus 9 meter. So lambda equal to 363 nanometer. So when you look at this wavelength in the emission spectra of hydrogen atom, you can see that this wavelength lies in the ultraviolet region of the electromagnetic spectrum. So here shortest wavelength, so we can substitute n equal to infinity. Okay. Second question, using Rydberg formula, calculate the longest wavelength belonging to Lyman series. In which region of the hydrogen spectrum do these transitions lie? Given r equal to 1.1 into 10 raised to 7 meter raised to minus 1. So you know that for Lyman series, the formula to calculate the wavelength is 1 by lambda equal to r into 1 by 1 square minus 1 by n square. So here longest wavelength is calculating. So we can write n equal to 2. Okay, for longest wavelength, the principal quantum number is n equal to 2. Then substitute here 1 by lambda equal to r into 1 by 1 square minus 1 by 2 square. So that is equal to, by calculating and arranging this one, we get 3r by 4. So lambda equal to 4 by 3r. After substituting the value of r equal to 1.1 into 10 raised to 7, we get the answer 1.21 into 10 raised to minus 7 meter. So that is equal to 121 nanometer. Okay, lambda equal to 121 nanometer. So when you go through the emission spectra hydrogen atom, we can see that this wavelength lies in the ultraviolet region. Okay, ultraviolet region. The third question is, the radius of the innermost electron orbit of a hydrogen atom is 5.3 into 10 raised to minus 11 meter. What are the radii of the n equal to 2 orbit? So you know the formula, the radius of nth orbit of the hydrogen atom, that is Rn equal to n square by m, h by 2 pi the whole square, 4 pi epsilon 0 by e square. And here the value of h by 2 pi the whole square, 4 pi epsilon 0 by m e square, the value of this quantity, that is the 5.3 into 10 raised to minus 11 meter. In theory, we studied that 5.29 into 10 raised to minus 11 meter. That is the first orbital radius. So, we can write Rn equal to n square R1. Okay, this whole value is represented as R1, where from the question R1 equal to 5.3 into 10 raised to minus 11 meter. So, from this equation, the formula is Rn equal to n square R1. So, here the question is, what are the radii of the n equal to 2 orbit? So, we can substitute n equal to 2. So, R2, that is radii of the n equal to 2 orbit equal to 2 square into R1. What is the R1 here? 5.3 into 10 raised to minus 11 meter. So, by multiplying, we get the value 2.12 into 10 raised to minus 10 meter. Okay, once again, here you know the radius of nth orbit, n square by m, h by 2 pi the whole square, 4 pi epsilon 0 by e square. So, this whole value, it is equal to the first orbital radius R1. Its value is given in the question, 5.3 into 10 raised to minus 11 meter, that is the Bohr radius. So, we can write Rn equal to n square into R1. So, R1 is given here. Then using the formula, radii of the n equal to 2 orbit. So, substitute n equal to 2, R2 equal to 2 square into 5.3 into 10 raised to minus 11 meter. Then you will get the answer of the radii of the n equal to 2 orbit.